On the night of February 27, 1991, a tense silence settled over the war-torn skies above Baghdad. Mere hours before the impending ceasefire, two General Dynamics F-111F aircraft, laden with mighty GBU-28 bombs, embarked on a dangerous mission toward a target on the outskirts of the Iraqi capital. Their destination was the al-Taji Airbase, approximately 15 miles northwest of Baghdad. The airbase had already endured the wrath of previous strikes, as F-117 Nighthawks had unleashed their GBU-27B bombs, leaving a trail of destruction and digging up the rose garden, as some accounts described it. The first F-111F approached the target site. However, with the weight of their mission upon the crew, they released the bomb, only to realize it had fallen off target. It all depended on the second F-111F now. Beyond reach. In the realm of modern warfare, underground military facilities present a significant challenge. Hidden deep within mountains or buried beneath layers of reinforced concrete, these facilities house vital command centers, ammunition depots, and research labs. Consequently, the U.S. military has developed specialized bombs capable of penetrating the Earth's surface or breaking through concrete to reach fortified structures. These remarkable weapons are known as bunker busters. During the land war that commenced on February 24, 1991, efforts were intensified to neutralize Saddam Hussein's underground command and control network. There was a rapid development of an innovative weapon as part of Operation Deep Throat, aiming to create a bomb that could reach the deepest levels of the bunkers in Baghdad. Buried up to 50 feet underground, these fortifications consisted of interconnected concrete chambers, housing command facilities for thousands of military personnel. They were equipped with 2-foot-thick concrete slabs and stocked with supplies to sustain occupants for extended periods. But existing technology had its limitations. For one, the BLU-109 penetrating warhead, equipped on the GBU-24, was not capable of such a monumental task. Hussein's bunkers simply lay beyond the reach of standard penetrating warheads. The situation called for the design of a bomb the likes of which the world had never seen before, and developers had less than 3 months to create it. Breaking through. The GBU-28 was developed within an unprecedented record-breaking 2-month timeframe. Aware that hostilities would break out on January 15, 1991, manufacturers were given 10 weeks to devise a solution. In order to achieve an objective of this nature, engineers and designers have 3 approaches they can take. The first option involves increasing the weight of the weapon, which grants it greater kinetic energy upon impact, enabling it to plow through layers of earth or concrete. The second approach focuses on reducing the diameter of the bomb, minimizing resistance during penetration, and allowing it to concentrate its energy on reaching deeper into the target. The final strategy involves boosting the bomb's speed by incorporating a large rocket engine, providing a powerful burst of propulsion to penetrate obstacles and dive further into the bunker. Auspiciously, a breakthrough came when a Lockheed employee proposed repurposing surplus M201 howitzer barrels stored by the U.S. Army as a suitable body for the weapon. 2 barrels were selected, modified by shortening and reboring them to 10 inches in internal diameter. Once completed, the bomb, called GBU-28 or BLU-113, measured about 19 feet in length and 14.5 inches in diameter and weighed a staggering 4,400 pounds. Basic physics. Encased within this robust steel structure was approximately 650 pounds of tritiorial explosive, a mixture comprising 80% TNT and 20% aluminum powder. Adding aluminum enhanced its brisance, a quality of explosives used to measure its shattering ability through its detonation pressure. Enriching the TNT with the powder increased the speed at which the explosive reached its maximum pressure. Consequently, tritiorial proved to be about 18% more potent than TNT on its own. At the front of the barrel, a laser guidance assembly was attached. Upon targeting the desired spot on the target by utilizing a laser beam, the bomb hones in on that specific location, aided by fins that steer the bomb towards its intended destination. Similarly, fixed fins attached to the rear end maintain stability during the bomb's flight. The GBU-28 functioned based on basic principles of physics. It featured a strong and narrow tube, which gained significant speed and kinetic energy as it fell from an aircraft. Upon impact with the ground, the bomb acted like a massive nail propelled by a nail gun. In a typical mission, the location of a bunker is determined through intelligence sources, aerial or satellite imagery. Then the GBU-28 is loaded onto a B-2 stealth bomber, an F-111, or a similar aircraft. While the bomb has been equipped with a delay fuse for post-penetration detonation, research has also been conducted on smart fuses, known as hard target smart fuses, which use microprocessors and accelerometers to detect and explode at the precise moment. On February 24, 1991, the first test took place at Tonopah Test Range, where a GBU-28B was dropped by an F-111 over the desert terrain, penetrating over 100 feet into the earth. The tests proved that, alternatively, the projectile could pierce through 20 feet of concrete. Only 4 days later, the GBU-28 bomb was deployed in real combat in Iraq. Ceasefire. The mission involved targeting command bunkers located beneath al-Taji Airbase, northwest of Baghdad, noteworthy fortifications that had previously resisted bombings by F-117A aircraft using GBU-27 bombs. On February 27th, 2 GBU-28Bs were transported to Taif using a C-141 transport aircraft. A weapons systems officer from the 431st Test and Evaluation Squadron accompanied the weapons to brief the 48th Tactical Fighter Wing crews, who were selected for the first mission using the new weapon. 5 hours after the bomb's arrival, 2 F-111Fs were loaded with the bombs. The 2 F-111Fs, named Cardinal 7-1 and 7-2, were capable of laser marking the target for each other or independently guiding their own weapons. During the mission, Lieutenant Colonel Ken Combs and Major Jerry Hust in the first F-111F narrowly missed the target. As a result, they quickly redirected Cardinal 7-2, flown by Colonel David White and Captain Tommy Himes, from its originally planned secondary target to the primary one. Subsequent analysis showed that the second bomb hit its intended aim point, and shortly after, smoke was observed surging from the air vents of the bunker, indicative of a powerful explosion inside. A few hours later, the dictator called for a ceasefire. During Desert Storm, the F-111E and F aircraft completed one last mission, while the GBU-28 bombs were incorporated into the United States Air Force's arsenal. Allegedly, the unexpected destruction of the supposedly impenetrable retreat may indeed have contributed to the Iraqi ceasefire declared the following day. If the conflict had continued, similar bunkers in Baghdad, serving as a last refuge for Saddam's high command, would have also been targeted. High hopes. In 1999, the U.S. Air Force deployed the GBU-28 bomb during the NATO bombing campaign in Yugoslavia. Tasked with targeting the Straževica command center, the U.S. Air Force had high hopes for its success. Unfortunately, despite their expectations, the bomb fell short of achieving its mission objective. Regardless of its shortcomings, the GBU-28 was given another chance to prove its worth in subsequent military operations. In 2002, as part of Operation Enduring Freedom, and later in the invasion of Iraq in 2003, USAF F-15Es utilized the GBU-28 to great effect. The bomb's reputation began to spread beyond U.S. borders in 2005 when Israel became its first international customer, acquiring 100 units. While there were reports suggesting that Israel deployed the GBU-28 during the 2008-2009 Gaza war, these claims remained unconfirmed. That same year, in the wake of North Korea's nuclear test, the United States responded by agreeing to sell GBU-28 bombs to South Korea. The delivery of these bombs was scheduled between 2010 and 2014, bolstering South Korea's defense capabilities. Even a decade later, in 2021, during the Israeli military's operation, known as the Guardian of the Walls, the GBU-28 did see extensive use in the bombardment of Gaza, further solidifying its role as a prominent weapon in modern warfare. Toward the end of 2021, the USAF completed assessments of a new bomb called GBU-72 Advanced 5K Penetrator, which is expected to be more effective against hardened and buried targets. Equipped with a smart electronic fuse that can activate at a pre-programmed location, the GBU-72 will likely become the replacement for the GBU-28 in the coming years. We're delighted to have you join us for this enthralling adventure. Please show your support with a thumbs up, and be sure to subscribe to Dark Tech for an endless supply of captivating content. As you embark on this journey, delve deeper into our dark documentaries collection. Make sure to activate the notifications bell to never miss an episode. Stay tuned.